We're actually just finishing up lesson 3.2 today with what's left to learn in it. And so what we're going to do here is the first learning goal that I have stated, but we're still going to also be accomplishing the learning goals that you had on Friday. So our new learning goal today. Samuel, will you read it for us?
I can represent a relation as a table, a mapping diagram, and a graph.
Okay. So we now are going to show the different ways we can represent a relation and the 3 ways we're going to use of the table, the mapping diagram, and the graph. Then we're going to also be practicing what we learned on Friday in those other notes that I had you take out. I can determine its domain and range. What's domain again? What's domain? I asked you to find the domain of a relation. What is the domain? Go ahead, Blake. It's the x values from the ordered pairs, because remember a relation is a set of ordered pairs. So the x values make up the domain. What makes up the range then? Talia? The what? The y values. Okay, so the y values of the ordered pairs make up the range. So we're going to be practicing still finding domain and range, and if it is a function. Who can tell us when we know if a relation is a function or not? How do we know if a relation is a function? Because Seth needs to hear it. He wasn't with us on Friday. How do we know when a relation is a function? How do we know that?
It doesn't have 2 numbers or 2 missing numbers.
What's it?
The x or y family.
So go to your notes. Let's go find something about functions in your notes. We got to be more specific. We can't say it because there's lots of things that qualify as it. Okay, a set of ordered pairs is a relation, but a function is a special relation.
If a function is a type of relation where each x value domain can be paired with only one y value range.
Okay, so a function is a relation where each x value can be paired with only one y value. It only has one y value and no more than that. So if any x value can be paired with more than one y value, that x value took away the opportunity to be a function. It is just a relation. It cannot have that special qualification called or name called a function. Okay? So let's take a relation here. We have this set of ordered pairs, -2, 5, -1, 1, 3, 1, and -1, 2. And we're going to write this as a table. Now, here are what we're going to do, and Mrs. Crevice and I will be changing my notes on this. In the table and in the mapping diagram, we are going to put the x values from least to greatest. Okay? The x values from least to greatest. So we're going to look at, we have 1, 2, 3, 4 sets of ordered pairs that need to be represented in this table. So we're going to look at the x values so we can do the x column first. Okay?
Isn't that what we did yesterday, least to greatest?
We did that in domain and range, yes, on Friday. And so we're going to do the same thing in the table and in the mapping diagram. So let's take our x values, but the only thing that's going to be a little bit different here is in the table, the x and the y values that are in the ordered pair have to stay together. They can't separate from each other. So what's the first x value we should list in this table? What's the smallest of the x values? -2, -1, 3, and -1. Blake? -2. So -2 should be our first x value. And then we're going to put the y value that goes with it. Okay? We can't worry about order for the y values. We have to keep the relationship going. So -2 and 5 belong together. So they're going to stay together in the table. Okay? What would be our next x value we should put in our table? Preston?
-1.
-1. Okay. But there's a -1 twice, isn't there? Yeah, so we're going to put it twice. We have 2 -1s. You have repeats in tables. We're not doing the domain right now. Or the range. When we do the domain and the range, we don't have repeats. But in our table, we will have repeats. So we'll just go with our first -1 has a y value of 1, and our second -1 has a y value of -2. And then we only have one ordered pair left. It has an x value of what class? 3. And its y value is 1. Okay. Now, the reason that we're gonna put them in order like that is because when we start working with graphing calculators and we go check out the table for a relation or for a function, that's how it's gonna put them in there. It's gonna go from least to greatest in the x values, and then the y values will be with them. So go ahead and graph those on that coordinate plane, because of course we did this as a warm-up exercise after your last quiz. Graphing ordered pairs, you should have 4 points to put on that graph. And we are not going to connect the dots. This is going to be a discrete graph. When you're done graphing your 4 points, will you look up and see if you agree with me, or if you try and change my mind, or any of them that I have at a different location than you? Is it you or me who is incorrect? Any questions? Do you have these? Okay. Then our last thing we're going to do is a mapping diagram. So we've displayed it as a table. We use that table then also to help us make a graph. And now we're going to make a mapping diagram. I want you to think of the mapping diagram kind of like this. In the first part of our diagram, that's really going to be our domain. The second one is the range. So we're going to, if you want to just even put up here that really what's happening is we are listing the domain and we are listing the range. That's really what's happening.
So can I just put x and y?
You can put x and y. But remember, what do we do in a domain? When we list all of the x values in the domain, how do we list them? Least to greatest. Any other restrictions? Anything other guidelines we use? Can't repeat. So, what do you think is going to go first in this one? -2. -1.
And then a 3.
And then a 3. We're not going to repeat that -1, are we? No. Now, this is where it might get a little bit confusing. We do not put the y values that go with them right next to them. We put just like we do in the range, we do the y values from least to greatest. From least to greatest, we do them in the range, so we're going to do them like that in here. So what y value is going to come first?
5.
-2, the smallest. Which one's next? 1. And then 5. Okay. And now we will be mapping. So now, that's why it's called the mapping diagram. Here's how you connect them. You say, oh, here's the y value that goes with that x value. And if there's more than one, then you map it to both of them. So -2, which one should it be mapped to?
5.
The 5. So we'll just go like this. We're going to arrow it down to 5. Those two belong together. That's how our mapping diagram shows it. How about the -1? The 1 and the -2. So it's going to have 2 arrows coming off of it. We're going to go to the 1 and the -2. And then how about our 3?
Goes to 1.
It goes just to 1. So now we'll have an arrow coming off of that one going to 1. Once we graph them and or put them in a mapping diagram, I think it makes it pretty easy to tell. Even though they don't ask us this question, I'm going to ask you, is this a function? Make a decision. Do you think this set of ordered pairs, this relation, is a function? Why not, Andrea? What's staring out at you? Okay, which one is it making it really clear to you in that -1 has more than one y value? Which one is really apparent? You're like, I look at this and I say, this can't be a function. Which of our 3 representations? The what? The mapping? Yeah, when I look at this right here, I say, you know what? I see that -1 is mapped to 2 different y values. So that tells me right there, son. You don't need to put that circle out in your notes. You might be confused what's going on, okay? That shows me that since -1, the x value, is mapped to 2 different y values, that's not a function. How we tell in the graph that it's not a function?
Because it just shows that there's just one area instead of
Oh.
two negative ones.
So like here, there are two negative, when x is equal to -1, there are 2 points, one above and below. So they're both sharing the same x value, but they have different y values. Yeah. Okay. In the table, is it as easy to tell from the table? Probably not. We might be, we might look at this and think we have 2 different x values going on here, but we really have one x value, but again, 2 different y values that go with it, don't we? So this one's not a function, is it? Okay, let's go on to number 2. Remember how do we put them in the table? What controls the situation in the table? The x's or the y's? The x's. Okay, so what order should we go? Yep. So where should we start? Okay, we got to look at all the x values. So 1, okay. Now we put the y values that go with each of those x values right beside them. What goes with 1? What goes with 2? What goes with 3? What goes with 4? What goes with 5? Go ahead and finish off now. You're going to put the y values that go with each of those. Oh, well, look at there. There's a whole lot of repeating going on, isn't there? Go ahead and plot those points down on the graph. What will that look like on the graph? They're lined up in a special direction. What's that direction called?
Arrow.
Horizontal. Horizontal. Okay. What are we going to do over here in our mapping diagram? What's that going to start out with? Okay. It's going to look just like our x value of our table because there's no repeats over here. So we can just really move that over and say 1, 2, 3, 4, and 5. What's going in the other?
3.
Just 1, 3, right? Just a 3. Because all of them have a 3. We don't need to repeat that. We're not going to make this look like our table again. And now we're going to map each of those to that 3 because each of them has a y value of 3. Now, even though they're not asking us this question, this is a function or not, I want you to decide, is this a function? Or is it not a function?
Mm-hmm.
These are the kind of tricky ones. They stump us, this one. Is this one a function? Remember, what's the definition for function? Not each number, what be more specific, each x value has only one y value. So is this a function? Yes. 1 only has one y value. What is it? 3. 2 only has one y value. What is it? Yeah. It doesn't say they can't share y values. It says they each only have to have one. They can only. And remember what we did up above? We said, oh, we could tell that this one was not a function because in the mapping diagram, -1 had 2 arrows coming out from it. It was being mapped to 2 different y values. Each of these only has 1 arrow coming out from it. They just all end up at the same location, but they each only have 1 arrow coming out. And in the graph, we said, oh, this is not a function because there we got points that are above and below each other. Do we have any points above or below each other in this graph? No, they're all beside each other, aren't they? So this one is a function, isn't it? We would say this one is a function. Each x value has only one y value. Okay, so now, why I did that with you is because guess what we're going to do now? Again, we're going to determine the domain and the range and then decide if it's a function or not. So remember, first thing we do is we decide when we have a graph, is it continuous or is it discrete? Continuous. Let's write that above. This is a continuous graph because once we identify that we have a continuous graph, that tells us we're going to be writing an inequality. Because if there's a continuous number of points on it, if there's so many points that we can't list them all, we have to state as an inequality. So what did we do before we did try to do the domain and range on this on Friday? Identify the what? Go look at your notes from Friday. What did we do when we were trying to do the domain and range for a continuous graph back on last Friday's notes? We figured out what? The values of the endpoints, right? Yeah, we did the endpoint values. So let's go on our graph and let's give names to these endpoints here. So what's this one and this one's ordered pair names? How about the one in the quarter? What's its ordered pair name? 0, 0, yeah. How about the one up here? 4, 4, okay. So we identify the endpoints first, because now we can say, oh, the domain is made up of the what? The domain is made up of the x's or the y's? Or the whole words? Just the x's, okay? So I want you to make your little, set notation, your fancy little bracket. And x has to be between what two numbers? It's 0 and 4. So it has to be between 0 and 4. So we're going to say 0 is less than or equal to x is less than or equal to 4. And close our set notation. So in other words, x can be anywhere from 0 through 4. Any point on that line falls in that region. Okay, now you try the range. What would the range be then? Using what we already practiced this on Friday, see if you can identify the range correctly.
That kind of looks like a 3 at the end.
It does, doesn't it?
And the little point plus 3 pointing to the outside.
So you want me to make that over? Is that what you're telling me, Adam?
Yeah, and then like plus 3 pointing to the outside. It just makes more sense.
This is there's a little pointy there. Okay. So anybody want to tell me what the range is? Holly, I would love to hear from you. Did you write anything down? Yeah. Let's just hear it. Give it a try. I'm feeling pretty confident for you. 0 is at this end. 4 is at this end. What's in the middle? Y. And is less than or equal to signs between. So we read it inside out. It says y has to be greater than or equal to 4 and less than or equal, or 0, excuse me. Y has to be greater than or equal to 0 and less than or equal to 4. Has to be between. It just turns out they both have the same beginning and endings, didn't they? But here's where we tend to sometimes mess up. We forget that the variable changes. So it's x is in the domain, it's y is in the range. Okay, next question, is it a function? And support for your answer. Explanations, we have to explain this. Is it a function? I so far got a yes and a no. Anna, what was your answer?
Said no.
You said no. Can you give us the reason why?
I think that because it's like
What would you have to look for? Andrea, what did you say yes? So Andrea says she thinks it is a function because all of the x's only have one y, or we'll probably say it better like this. Each x only has one y value. So in other words, each x has only one y value. Adam, you're not convinced of that. Could you?
no,
You know what?
because
Disprove Andrew by picking out an x value that does not.
the 4.
Okay, the 4. So when x is equal to 4, you're telling me, so right here, when x is equal to 4, you're telling me that there's more than one y value for it. Are there 2 or 3 or 4 or more points that have an x value of 4? Are there any other points that have an x value of 4? No. So there's only one y value, isn't there? Think of that. Remember what we did up here? Remember what we said? This one I said would be a function because we had no points above or below each other. this was not because we had those 2 points above and below each other. If we made a bunch of points on this little line segment, basically you could just keep making points on it, would you have any points above or below each other? No. So this is a function, we would say yes. And we would say each x value has, we're going to say exactly 1 y value. There's not another one on that graph for any of those x values. Each x value has exactly 1 y value, or only 1 y value, you could say. No its are allowed in this. We don't know what it is. Each number, we don't know what you're talking about when you say number. We have to be specific like this. Each x value has exactly 1 y value. Okay, questions? When we have a mapping diagram, it makes it really easy. What I don't like is that this one did not do what I want you to do, but it makes it really easy to pick up the domain and range. Because what's the first oval, or in this case it's kind of a rounded rectangle, what's the first one represent? The domain. And what's the second one represent? The range. So can't we just go like this and say, oh, the domain is what? What's that? Thanks?
8.
8, comma, 9, yeah. Least to greatest. So they did do the mapping diagram least to greatest for that one, but they didn't for the next one. So I am going to say we got to go back to remembering though, when we do the range, we're going to do it from least to greatest. So we have to start with what for our range? Here's our range over here. Where should we start? -9, -6, -4, -3. No repeats going on. There shouldn't ever be repeats going on in a mapping diagram. It should be easy just to pull all the numbers, make sure you include them all, least to greatest. -9 is smaller than -3. Okay, you decide, is this a function?
No.
And if we say no or yes, it doesn't matter. We have to have, support. So, no, why is this not a function? That's what I'm hearing the most here. Why is it not a function? Can we be specific? Maisie?
Because the x values share more than 1 y value.
Okay, so we can say no, we can say which specific x value. Let's just even be more specific than that.
8.
The x value 8 has what? How many? 1, 2, it has 3 arrows coming from it, doesn't it? It has 1, 2, 3 arrows coming from it, so it really actually has 3 different y values. But you could also pick on another x value. What other x value could maybe your explanation have used instead? -9, and then you would have said the x value of -9 has,
It's just a regular.
oh, is it just, oh, yeah, I'm sorry. The x value of regular 9, if you use that one instead, what would you say? Has how many different y values?
2.
2. That one has 2 arrows coming out from it. So if you use that one as your explanation instead, you would say the x value of 9 has 2 different x or y values. Okay, you go ahead and try number 5 on your own. Try it on your own. You need to start with listing the domain, then go to the range, decide if it's a function, explain. Are you done with it, Andrea? You are teaching. Come on up. You just have to fill it in. I won't make you talk. Unless you want to, of course. You guys do it on your own. Andrea's just gonna, share hers, and are you gonna check to see if you agree with her when you're done? if you are done, you can check to see if you agree with Andrea. Thank you, Andrea, for doing that. Or any part that we want to, challenge or encourage her to be more specific or anything. Okay, I'm gonna ask for a little bit more specificity in the explanation. I agree with that it's not a function. Anybody have something more specific in their explanation that said no, because it is not a function? I'm gonna agree with her there. So, Andrea, do you know which x values have more than one y value? Do all of them? Does each x value have more than one y value?
Just 1 and 2.
Just 1 and 2. So in our explanation, we'd have to use one of them, wouldn't we? We could use them both, or we could use one of them separate.
Put the x value 1 and 2 and have two different y.
Okay, the x values 1 and 2. We would say, how about we do this? So can we just add the word each in there? Each have, because they're working independently. They each have more than one y value. Yeah, good. We could do it that way. We could say the x values 1 and 2. I snuck that in between here. Each have more than one y value. Okay, questions? If you didn't do it right, take the time right now to use Andrea's work here as your notes to fill in. If you do have it done, do not put these notes away. That is not why we take them. It's to fill up your binder to empty out at the end of the quarter or semester. Anybody need this up here longer?